Let's get started. It's 4 o'clock on a Friday. That means it's time for Research with Relevance. Welcome, everybody. I hope that you all had a chance to join us the last time we met. 2 weeks ago, we had a very lively discussion with several of our colleagues in engineering, Laura and Rich Ruhala and Lance Krim. The show went by so fast because it was so fascinating. If you missed it, please go onto YouTube and you can see the video. My name is Phaedra Corso. I'm the Vice President for Research, and I'm very excited about today's episode. It's an important topic. It's timely. It's relevant to the world and everything that's happening in the world, and so I think we'll have a good time. The reason why we're doing these Research with Relevance shows is because we have some really outstanding researchers across KSU, and we want to give you all the opportunity to meet them. And it's also a way for us to stay connected during this very strange time that we're living in. And I kind of like the format. I'm getting a little tired of Teams, as I'm sure you are too, but I like the format because it allows me to see many colleagues that I might not see on a regular basis. So for that, we'll probably keep going in this way for a while. Before we get started, a few housekeeping tips. First, please make sure that your mics are muted if you're not speaking. We'll be opening it up to questions and answers at the end, as we always do. Second, I'm sure you all are experts on Teams by now, but if you didn't know, you can click on the 3 dots next to someone's name, and that will pin that speaker and have them be full size on your screen. And then finally, just as a reminder, this episode is being recorded, and we do that because we want to post it on our YouTube channel for those who aren't able to attend today to be able to see it at another time. So our schedule for the next hour is the following, and we haven't changed the format since we started, so it shouldn't be a surprise. We're going to start with a video, and today's featured faculty member is the shining, smiling face that I see right there is Faruque Hossain. We're so excited for him to be here today. And so then after we see the video, I'll open up with some questions. And then if you all would like to ask questions, please feel free to use the chat function if you have that available to you through Teams, or you can raise your hand through Teams, or you can show us your face and raise your hand in real time, and hopefully someone will notice and will call on you to ask your question. So let's begin with an introduction. So we're happy to welcome Faruque from the College of Architecture and Construction Management. He is the first College of Architecture and Construction Management faculty that we're featuring on this show, so we're very glad for that. Faruque joined KSU faculty fairly recently ago in fall of 2019. And he left behind a 15-year career in research and industry. And so, of course, we're going to be asking him, why on earth did he leave industry to come to KSU? So we'll be asking that question. And his industry practice has been in the field of construction management for both private and public sector projects. He's specialized in large-scale buildings, civil, energy, environmental, and critical infrastructure. Originally from Bangladesh, Faruque earned his master's degree from, I might not pronounce this correctly and I apologize, Shimane University in Japan, sorry, as a Fulbright scholar before receiving his PhD in environmental science from Hokkaido University in Japan. He then completed clean energy technology research supported by the Australian Research Council postgraduate scholarship. So now we're about to watch the video, and before we do, I just want to send out a few thanks before I forget, because I always tend to do that. As always, I would like to thank Joelle Walls, who is my communications director, who is outstanding in every way. Tom Boyle has been instrumental in helping us pull these videos together for the show. And I also want to send a special thank you to our 2 student assistants who are working in this office this semester, Dorothy Corbett and Jacob Segura. We do a lot of outreach and communications and marketing for the great research that we do around KSU. We're happy to provide those services to you all if you want to get the word out about the great work that you're doing. And we rely heavily on our student assistants to help us do that. So we just wanted to send a big shout out to them. So with that, I'm going to turn it over to, I'm not sure who's running the video today, but I'm going to be quiet and let the video run.
Hello, my name is Faruq Hussain. I am an assistant professor of construction management in the College of Architecture and Construction Management. During a high school science class in my home country, Bangladesh, my teacher told us that Earth will not survive for very long. I was surprised and asked my teacher why this was the case. She explained that we are consuming all natural resources at such a rapid rate that very soon we will have exhausted of all gifted natural resources of the Mother Earth. If the natural resources are no longer available on Earth, how can all forms of life survive on Earth? I had no answer at the time, but this was a pivotal moment that I made a big impact on the type of career path I would be seriously considering for my future. I made it myself a mission to become a responsible steward for the planet's resource and help others in doing the same. Then I admitted to pursue my undergraduate degree in environmental science so I could learn much more about Earth's natural resources and thought about conducting research in the future to protect those natural resources. I subsequently received a master's degree in environmental science and also another master's degree from Shimane University in Japan, which I was invited by the Japanese Ministry of Education, Culture, Sports, Science and Technology to complete research in environmental science as a Fulbright scholar. Finally, at the Hokkaido University in Japan, I have conducted much more advanced level research in environmental science to finish my PhD. Later, my environmental science research was boosted by the Australian Research Council postgraduate scholarship, which allowed me to investigate clean energy technology application for securing global sustainability. Research is urgently needed now to define the context of the human impact on Earth resources that is severely affecting the biodiversity in order to address the planet's healing process. We must think through the scientific theories and practical applications using a holistic approach of the problems and the solution to mitigate these effects. By using evidence-based research to develop and improve sustainability practices focused on the environment, energy, water, housing, building, infrastructure, and transportation, we certainly can secure a better planet for our future generation to enjoy. For example, fossil fuel consumption used in traditional design and construction practices in the building and infrastructure sector not only causing the finite levels of natural resources, but also causing a severe climate change crisis by releasing billions of tons of carbon dioxide into the atmosphere. Interestingly, my research has revealed that if a mere of 0.01% of Earth's annual available renewable energy, such as solar power, is used for sustainable design and construction, this will satisfy the net energy demand for the entire world, which is environmentally friendly. Simply put, application of natural resources wisely by conducting sustainable design and construction practice shall indeed secure a zero-emission housing, buildings, and transportation system throughout the world. During my tenure at engineering and construction companies for the last 15 years, I realized that we are accelerating the tremendous crisis affecting the environment, energy, shelter, and infrastructure by practicing conventional design and construction methodology. We are depleting the natural resource rapidly as well as causing a deadly environmental crisis that will not support living beings in the near future. Therefore, my life's work is focused on implementing sustainable design and construction practice. As a result, I left my executive position at a Fortune-listed 500 companies 2 years ago so I could share my research and professional experience with the student of Kennesaw State University College of Architecture and Construction Management with the ultimate goal of protecting Mother Earth.
Great. Thank you. Thank you for that video. So, Faruq, welcome. I want to read some quotes from your video, okay? First one, Earth will not survive very long. Number 2, deadly environmental crisis that will not support human beings in the future. We are consuming all of our natural resources. These are doomsday quotes that I'm reading to you, and I guess I really want to hear from you, the expert in this field. If we were to do nothing, if we were to continue on the path that we're on now, what does the trajectory look like for us as humans?
Okay, so let me give an example. So for example, so at this point, we have a real, calculation for the total energy in the planet. It is a calculation made by the Shell, as well as ExxonMobil, British Petroleum, as well as my own research. And we found that the total global energy reserve is a combined for coal, gas, petroleum, everything is about 36,000 exajoule. So basically, we are using every year approximately 600 exajoule. It means that within next 71 years, so all the complete fossil fuel reserve will be finished, period. So it means that, so ultimately, we have to find some other sources or some other things. So because at this point, as I said, so the way we are consuming all the natural resource, because the fossil fuel is a kind of natural resource. So therefore, it will be finished within 71 years. So therefore, we have to find some kind of alternative technology. Mm-hmm. So this is one example. So there is also several others example too. So therefore, so for the construction industry, so for example, we have been using a lot of timbers. So you probably know the tree is the main part for balancing for the earth oxygen. So the way we have been using all the timbers, and this will be about within 300 years. So probably we'll have a severely shortage for the timbers. So this is the things, all this natural resource, what we have been using nowadays for the conventional design and construction practice, this is a really, really alarming for us.
Okay, all right. So that's the negative part of this hour. Now we're going to talk about some solutions. I hope. Can you give me an example in your own, either in your work in industry or in your research, where you are looking at alternative resources to put into construction management? So like, what is it is it wind? Is it solar? Is it nuclear? What is it that you're most excited about as the future of this planet?
Okay, I do have a solution, because we don't have to worry about that, even though after 71 years, we don't have any more, fossil fuel or something like that. So basically, the solar energy, I have conducted my own research. The solar energy available on Earth, which is about 10,000 times more. So what basically we need every year. So therefore, implementation of the solar, and we have been talking for the last 50 years, we have a solar energy basically. But basically, we have no any kind of practical application. So if we use this solar energy by doing advanced design technology. So for example, for any kind of high-rise building, at least 25% of the building's exterior skin, curtain wall skin, can be used as an active PV panel. So it means that it can capture the solar energy and it can generate the energy for that building completely.
Okay, but so it sounds like the solutions are there, the science is there. Why aren't we doing it?
Well, basically the reason, I believe most of the people doesn't know. And in fact, we are basically very much habitual about using for the traditional design method or some kind of things. So therefore, we have to change our traditional method. So we have to know that this is the traditional method. What basically we are doing, this is not a right at this point, because we have only 71 years. So within this time, we must have to think to change our design strategy as well as construction strategy. So if we change that, so because we have to know that, we have to tell everybody that this is the advanced design technology, we definitely can change and we really can use it. So that's what we have to do it.
Okay, so then if it's just a matter of, training the next generation of construction managers, builders, architects is it required as part of the training that that you do with your students, that they learn about sustainability options? Is it a requirement or is it an elective for your
Well,
field?
I personally believe, as I said, it should be requirement, because ultimately, as I said, within a certain period of time, we don't have any other options. So therefore, it should be requirement, because if the student, especially the student knows that, so we have an alternative source, but if we can somehow implement the alternative source for the design and construction technology, ultimately we don't have any kind of problems. We shouldn't have problem in future. So therefore, it is my personal belief. I strongly believe that we should have some sorts of education or training to the student. They should know it. So therefore, after their graduation, when they will go for the industry practice, they can really implement the technology for the sustainable design and construction.
So you moved from industry into academia. I can only imagine that transition has been interesting. So, and your video talks about it a little bit, but I would love to hear in your own words now on why you made that transition. What about academia has surprised you, and what do you think your greatest contributions coming from industry to academia have been so far?
Well, basically, I was the industry, I was in the industry for the last 15 years, and basically doing, sustainable design and construction practice. And I also realized that, so even though we are planning to do sustainable design and construction practice, but because of there are some very high level project, because of the stakeholders' demand as well as some kind of issues, we are basically not following the rules to conduct sustainable design or some kind of things. So then I realized that, okay, so probably, I should have, what I had been learning from this. Basically, it is not only few cases, I would say maybe 20% cases I was very successful when I gave my thought. Okay, so the building, we probably have to completely sustainable design and construction. 20% cases, they really realize that. And 80% cases, they said, okay, now we have been doing this kind of design for the last 50 years, and it is the demand for the stakeholders. And I also told them, so although it is the demand for the stakeholders, and basically we have to change this strategy. So anyway, then I realized that, so probably, it is time. So after 15 years, it is time, probably I can find a full-time job in an academic position, and where I can do the conduct research as well as I can teach my experience to the young student, because those young students are the future for the world. So if I can teach them, that's the sustainable design and construction is the urgently demand for the world survival. So that's the reason I said, okay, now it's the best time to go back to in academia.
Great. Well, we're glad to have you.
Thank you.
So let's talk about specifically what is it that you're wanting to research. So you've been, you come from a great research background. You've worked in industry where you've had a great application, I'm sure, of much of what you learned in your doctoral training. But what's the future of research for you now?
Well, right now I'm conducting research, the solar energy application for the sustainable design and construction for building sectors, as well as infrastructures, as well as the bioenergy, the domestic waste. That's the domestic waste. Every day we have a domestic waste. The waste can also be implemented by using bioreactor in-house and to use the bioenergy, which can also supply for the entire buildings too. These are the two main topics I've been doing research. And recently I'm also working, so if I can introduce the solar energy into the transportation sector, the solar energy. So basically, I'm also thinking, actually, I have started to do research on that. So approximately 30% energy is consumed by the transportation sector. So if we can somehow implement the solar energy into the transportation sector, it will be a great relief for the whole world. That's what I've been doing now.
Will you give me an example? Because I cannot even conceptualize how one could do that. So just give me a small example.
Same thing. So for example, right, if we have a kind of car or train, so if any kind of train, so at least 25% of the train solar exterior wall or maybe the roof, it has been designed by advanced solar panel. It can capture the solar panel as sunlight, and the sunlight can automatically convert it into DC current to AC current, which can completely supply the energy for the train, and the train can run. So this is the thing I'm doing now.
It sounds absolutely fascinating, but as someone who might be a decision maker or a policy maker, it sounds super expensive. Is that true?
Well, at this point, let me tell you something. So it is very beginning of the level. Any research, so people will be thinking, so it is expensive. But if we think about for the 30 years long-term goal, because I also have a model about that. So because I have realized that, okay, initially, if I use for this kind of solar panel, looks like a little expensive, but if I go for the 30 years for the energy modeling, so finally it is a tremendous cheaper than what we have been using now. So therefore, we should not be worried at all because we have a complete, modeling for that, energy, saving modeling on that, cost saving modeling on that.
Yeah. I'm all about showing returns on investment and doing long-term modeling in particular to show that. But unfortunately, the person who pays for it now doesn't reap the benefits later. So it's such a hard, it's just such a hard sell for us to be thinking long-term when it comes to environmental policy.
Well, basically, let me tell you another thing. So for example, right, if you think about the electric car nowadays, we're running. So electric car, probably you may think, oh, okay, it looks like a little expensive. But of course, the electric car is a very new technology, right? So think about that after 10 years. So the technology will be much more developed and naturally cost will be much less. And this would be definitely a plus. As I said, the most importantly, we have to think about our Earth. If the Earth doesn't survive, we have to think it very seriously. If the Earth doesn't survive, so those time, we have to think, of course, cost is a concern, but first we have to think, so how to protect our Earth and global environment. That's the #1 priority at this point.
You have converted me. And in the 15 minutes we've talked, I'm converted. I want to save our planet. Now, if I could give you an unlimited amount of money to do anything right now to save our planet or to do research to save our planet, what would you do with the money?
I will hire unlimited postdoctoral fellow researcher and hundreds of undergraduate students. That's my dream. Simple.
Okay, so you're going to hire all these students to do what exactly?
So basically, the sustainable design and construction practice. So basically, for the student, okay, I will tell them. So because student doesn't need to do all the details of research, for the basic fundamentals. For the sustainable design and construction that I'll give training all the students. And of course, as I said, I have an unlimited postdoctoral fellow researcher. I will tell them, okay, do research, sustainable design and construction, and make this case is the #1 sustainable design and construction institute in the whole world in the next 10 years. I'll do it.
Okay, I love your enthusiasm, Faruq. I see some people have jumped in, so I'm going to. I see you, Ian. Do you have a question for Faruq?
Yes, I do. So I've done a little bit of work in both solar, solid state lighting of that. When I look at the US, the thing that concerns me is our power usage just on average is about 100 quadrillion BTU. The use of power in the world, right, is about 500 quadrillion BTU, roughly, right? The US is about, 1/20 of the world population, and it uses about 20% of energy, right? You've talked about both the ability to generate through solar, and solar is doing well now. You can install about 2 to 3 cents per kilowatt hour, depending on the region, right? But if you want to try and solve this problem, and to look at sustainability, the US is a good model, right? We in some sense lead the world in a system that may not be as sustainable, right? So there's generating energy, there's saving energy. So solar is generating, saving. You know, solid state lighting, we probably saved about 1 quadrillion BTU in this country using LED lighting, maybe 2. What's the way to go? And if you're looking at this country as a model for it, because it's not sustainable at this time worldwide, in some sense, the US makes it less sustainable. What would you be doing? And when you've talked about your research, maybe talk something specifically about technologies that you're looking at that would help us to do that. If you Sorry, my questions may be a little too long and convoluted. What would it be, right? What do you come in and think about, and what do you do in terms of developing the technology?
Okay, let me tell you first. In fact, you know, in America, what we are doing, the uses of the solar energy as well as other, you know, sustainable energy technology, comparing even also some other developed country, is very limited, very, very limited. So basically, so we are not fulfilling. Actually, we have a plenty of resource and plenty of, you know, technology. If we really interested to use all of the solar energy technology, we really can do a lot. But unfortunately, up to now, you know, the way we have been using the solar energy in America basically is not satisfactory at all. And we have to think about that. You know, somehow the technology, what I've been talking, so the direct technology. So if we can implement all of the advanced design technology to use the solar energy for the building and housing sector, would be really, really cheap. And of course, there is some concern if we do some kind of solar field, approximately hundreds of miles, you know, solar panel, and, you know, convert into through the national grid or some kind of thing, that is expensive. So my technology, I'm not talking about that one. Just I made it very simple technology. So directly all the solar panel can be installed any kind of, you know, housing and the building sectors, and it can be directly transformed to DC current to AC current, and we can use it. So this is much more convenient technology, and we probably should think about that.
So I just have one follow-up question with that then. You know, you obviously have cost of ownership models sitting and relative to efficiency. So what efficiency do you need per unit area or something for your solar cells to make this viable? You know, silicon sits about, you know, 18% efficient in that, but it's a larger area. I've worked on multiple junction cells to make things that are smaller, but it's always driven by both the cost of generation relative to traditional surfaces, relative to traditional sources. And it's also driven by the ability that if you're covering a building, when you need to get the efficiency, plus architects like buildings to look beautiful, they don't want them to look like a solar cell.
Right.
So maybe you could tell us something about the cost versus efficiency, and those breakpoints coming out 5-10 years of that for implementation in specific applications, for example. So maybe just a little bit more detail would be useful.
Very good. Thank you for the question. So basically, you know, all of my research I have conducted, the efficiency I have used 15% only. 15%, because it's very much calculated through the solar irradiance. 15% I have used that one. And at the same time, I have to tell you that there are some researchers in Japan. They are trying their best to make this efficiency up to the 25%. They are not successful yet, but they are working on it. Somehow I have a very good communication with them. But all of my research, as I said, I have showed the efficiency is 15%. And at the same time, I also made an energy modeling that what we have been using all the energy from the current utility source, as well as my 30 years in a solar panel goal. And ultimately it has found that it is cheaper. So if I use any kind of the solar energy technology, but as I said, we have to think about that the long-term goal.
But cheaper, how far out? Where's the break even point? Because I think that's what a policymaker really wants to know.
Well, break-even point, I would say probably within 10 years, it should be, if I think about the 10 years, right? So within the 10 years, it should be completely break-even point.
Andrew, do you have a question?
Yeah, I'm gonna take a big step in a different direction with Faruq. You know, looking at your breadth of research over the last 20 some odd years, from what I've been able to read and the documents you're producing now, you know, as faculty in the construction management area, you know, there seems to be a lot of experience that you have with the nanotechnology and metals and applications in industry. How do you translate some of that research into what you're doing currently in CM? And if you talked about this already, I apologize. I joined just recently, but that's an area that, you know, I passed you in the hallway today. I wanted to chat with you about, but we're in a great venue right now for me to ask, you know, how do you tie your extensive research from industry into what you're doing, you know, currently now? Where did it lead you?
Thank you, Professor. I just like to, you know, that's a great question. And basically, you know, the industry level, what I found, so basically I saw that, you know, I was involved a couple of projects. They just, you know, installed for the very standard solar panel, very standard solar panel. And recently, you know, I was written a paper. It has been published about 7-8 months ago. I also model, so by using the nanotechnology, so it means that the photon particles, so there is a possibility the photon particles can be split into 1 photon particles into 4 photon particles. So therefore, the energy level, what we basically were reaching on Earth, it can be 4 times more. So that's why the paper was designed a micro PV panel. That's the paper I have written, and it has been published. So therefore, using this, the nanotechnology would be really, really interesting because it's a very much theoretical at this point. That's what I've been doing. So in future, if it can be really applicable commercially, so within 10-15 years, I think it would be a completely revolution in the whole world. So basically, you know, that I need some sorts of, you know, some more people who will be helping me out doing this. I'm just, you know, single when I'm doing, you know, I work, you know, what is that like? I came to the office almost 6 days. You know, I'm trying my best. Let's see what can I do. That's what I'm doing.
Good, thank you. Thank you, I appreciate it.
I think Dean Payne, he's asking for a lot more students to help him on his research, is what I'm hearing. And I see that I have Chris Cornelison is a participant. He's our director of IP development. And if you get to the point where you're developing product and you need some advice or mentoring, then please reach out to Chris. I'm sure he would be happy to do that.
Sure.
So let's talk about your students. So I know you're doing a lot of teaching right now, but do you have an active research lab or team? And if you do, are these undergrads? Are they graduate students? And I'm going to add another question to that, which is, if I'm a student and I am passionate about saving our planet like you are, what is my career path? Do I need a PhD in, you know, in material science or any of these other fields that you've been talking about, or can I get, or is there another pathway to do this research or to do this, to be this passionate about what you're doing?
Okay, let me give you the answer one by one. Basically, you asked me 2 questions. The first question is, right now I'm doing research alone. I'm a lonely wolf. But I'm looking for some collaborator. It would be great, because it would be great. So basically, you know what? So all of my research at this point is a very much theoretical. Of course, I have a practical experience in the industry. So therefore, at this point, I don't have any lab, but I would prefer, as I said, if I have a collaborators, at least, you know, 4 or 5 postdoctoral fellow or at least 10 student would be great, would be really, really great help. And that actually I'll be looking for. And let's see how does it happen. And the second one is your questions for the student. Student doesn't need any kind of PhD or master's at all. And see if any kind of undergraduate student who is really interested, actually a couple of my students are interested, who is a real interest, so basically one semester, if I can coach them for the sustainable design and construction technology, that would be good enough. They don't need any kind of PhD or some of stuff. And as I said, within my 1.5 years, I realized the students are really, just the young fellow are really interested, and I see that they're really keen to learn. So, and I'm sure that once I have available everything, the resources like, manpowers and everything, I'd be very happy. As I told you, what is that called? I was in the industry, and I personally, financially sound. I personally, because I was in the, the 15 years in the industry. So all I'm looking for a very nice collaborating team and some sorts of research facility, and I should be doing, probably my dream will be fulfilled.
I hear you. Ian, do you have another question? You are unmuted, so you're welcome to ask a question.
Okay. So a lot of it you've been talking about generation of power, and very often, as you know, generation of power always has wasted power. So in terms of saving the environment, the wasted energy is really part of the issue. Have you looked at how to save and make more efficient systems for saving energy? Because the approach of just generating more may not take us where we need to be.
Let me give an example. Average, we have a statistics. Any kind of fossil fuel, right? Gas, petroleum, or coal, what I've been using, it is at least approximately 20 to 25% waste during the process. Waste. It's tremendous. So that means that it is not only wasting for the energy, it is also causing the serious trouble for the environment. But if you think for any kind of sustainable, renewable energy like solar, like wind, right? We don't have any kind of waste. Very limited, very limited. It's a very limited, amount for the, waste for this kind of energy. And even though it's a waste, but the good thing is it is not bad for the environment. It is basically good for the environment, whatever is the waste. So therefore, as I said, so always we have a risk for those kind of fossil fuel and some other stuff. But of course, as I said, until if we get any kind of, developing all the sustainable design technology, and we should be using this one, but at the same time, we have to think about the advanced level. So make sure that we really can use all the sustainable energy technology for us and for our future generation.
From a design, from a design element, I get it, but I'm still kind of stuck on this worry about costs and what can we do as, as policymakers to kind of push us in the right direction. And so we see, at the national level and sometimes state level, we see some incentives for sustainable construction designs. In your opinion, do you think those policies have been helpful? Has there been an uptick in people, changing the materials that they're using, or at the end of the day, has it just fallen flat?
Well, I would say at this time it's falling flat. Actually, basically we did not, achieving our goal yet. So basically achieving the goal for that, sustainable design and construction technology. So we are completely flat, because ultimately, I saw that many of the buildings when I was in the industry, so many buildings and infrastructure. So basically, initially they are thinking, so probably, so my goal ultimately may be platinum, LEED platinum, leadership, energy, environmental design, LEED platinum. So finally they changed their decision. Okay, so no, because if I go for the LEED platinum, so probably the project will be a little bit more. They don't think initially maybe a little bit expensive, but they don't think about the long-term goal. The building is not only for 1 year. The building will last minimum 50 years. But as I said again and again, it's my real experience in the past. And as I said ago, it is the owner's demand. Owner even doesn't know if it's a $500 million project, owner doesn't want to spend another $10 million more. I said, if the owner spend this $10 million more today, the building will last 50 to 60 years. And within the 50 to 60 years, we are saving minimum $30 million energy cost. So basically, as I said, it was my real experience. We are completely flat, and I can even consider we are behind on it.
Yes, I'm with you. All right, we have a question that's come in from the chat from Nikki, who asks, who decides where to source materials for a project? I would imagine if you need X amount of steel for a project, it would be more sustainable to source from 100 miles away instead of 1,000 miles away. Are those kinds of decisions part of sustainable design or important to a sustainable design? Excellent question, Nikki.
Excellent question. So basically, when you think about the sustainable design and construction, it is one of the criteria, location. So basically, if we try to buy steel material within 100 miles or 10 miles, or another steel I'm buying thousands of miles, ultimately the transportation cost. Transportation cost means fossil fuel cost. So naturally, if I buy any kind of steel material or any kind of construction material thousands of miles distance, it is absolutely not a part of the sustainable design. If it is 100 miles or less, this is a part of the sustainable design and construction. Excellent questions. Thank you.
For those of you who would like to ask questions, feel free to raise your hand or put more in the chats. Everyone except for Ian. I'm just kidding.
I do have one more for later, but I'll let other people jump in.
Okay.
I'm just kidding, Ian. You go right ahead.
So my question is for part of what we want to do is to build a sustainable research program here, and that comes from our ability to be able to raise funds from different outside entities and also different government agencies. I'm familiar with a number of them where this may fit. So who are you currently writing proposals to create a sustainable research program? What agencies and why? And the reason for asking is I know a number of these agencies and some people in them. So give us some ideas of how you're going to build a sustainable research program that's externally funded, and who you're looking for to provide that funding.
Well, at this point, we have several funds, National Science Foundation, Department of Energy, those Department of Environmental Protection Agency. So those would be if we think about the federal grant, those would be those three agencies would be the #1 priorities. And in the meantime, I already applied for NSF Career Award. I already applied for this fund, and I'm thinking, so because I'm tied up because I'm writing another book, so I have to finish it up. So I'm thinking, so probably I'm going to organize a big team in this university as well as collaborating with other universities. It's a big research fund that I'm thinking, so it's from the NSF. So that I'm thinking. So at the same time, if the universities also try their best, so to get fund, National Science Foundation, Department of Energy, and I believe, I don't have any idea about the Georgia State. Georgia State might have some source of the fund. So that probably would be another, source for the fund. So that's my thinking. So at this point, my priorities is National Science Foundation, Department of Energy, and those would be the #1 priorities. Probably we should give attention to get some fund.
Faruq, what is the book that you're currently writing? And I know you're very humble because you've written several books, but let's hear about the next one that you're doing.
My first book is Sustainable Design and Construction, published by Elsevier. The second book is also mass development of sustainable urban development. It is also Elsevier. The third one is Global Sustainability, Energy, Environment, Building Infrastructure. The fourth one is Sustainable Design for a Global Equilibrium. It will be published by Springer. So
what is it? what does that mean? What does the back of the book jacket say the book is about?
So basically, all of the sustainable, using the sustainable energy system, sustainable design system, and sustainable construction system, how basically it will make the total environmental equilibrium for the whole world. That is the goal.
And if you're thinking about this on a global scale, which I know you are, what countries are far ahead of anybody else in this on this topic?
I would say almost every country. So basically, if we think in none of the, including all the developed nation as well as developing nation, everybody is far behind for any kind of sustainability, far behind. And many countries even don't, especially for the developing nation, many countries even don't think about the sustainability. The good thing is, so we are, in a developed country, at least you are thinking to do something sustainability. So therefore, if you think about that, I would say almost every country. But we are in a better position. We are in a better position comparing the developing nation.
But I mean, in comparison to the developed countries, is the U.S. ahead of everybody else? I can't imagine that's the case.
Well, the U.S., there is a couple of countries like Germany, French, Japan. In fact, they're ahead of us for the sustainability. And in the German, they have approximately, so they have the highest number of the solar energy application for the building sectors. In Japan, that they don't have any natural resources, so therefore they have been trying their best to use all the sustainability for all of their building sectors and others. So in that comparing few other developed nations, we are still behind. But the good thing is we are thinking to do something better.
All right, well, let's bring us back to current events. So we just saw, a crisis of energy, all sources of energy in Texas, given the severe weather issues that they had. And, I heard differing reports. One report saying it's because we have all these wind turbines that froze up. And then I hear another report that says, no, they didn't winterize the energy systems they had in place. So as our resident expert in sustainable materials and energy, what should Texas be doing? What happened there? How can they prevent this situation from happening again?
Well, so with my, so far I knew that in the Texas, this kind of accident happened, the reason, so what I understood so far. So basically, so we use the fossil fuel burn, and then through the transmission line, 100 miles, thousands of miles, right? And through the substation, and we supply the energy. So basically, the Texas probably did not do any kind of, when you supply any kind of, energy through the transmission and as well as the underground supplying system, probably they did not provide any kind of heat tracing system. What does that mean? It means that, so any kind of, when the temperature fall below, so there is a possibility that everything get freeze. So therefore we have to provide some kind of winterizing system or maybe heat tracing system, make sure that all the energy can flow, is a kind of, can flow. So somehow it is my thinking, I don't know all the details. So somehow probably they did not provide any heat tracing system, or probably they did not do any kind of wintering system. So that's probably the reason this accident happened. So in fact, as I told you that this is basically fossil fuel, is a thousands of mile transmission. If we have any kind of sustainable energy, like, I have energy that can produce the building automatically from the solar, I shouldn't have this kind of problem.
Good, thank you. All right, we have 10 minutes left. So if there's questions out there, please have them come in. We've got one from Joelle. She asks, can you give me an example of clean energy technology application you worked on while in Australia?
Well, in Australia, basically, I have used all the, those time I was a postgraduate researcher. I was not an industry practitioner. So basically, it was I have done the research, everything theoretically in the lab. So unfortunately, it was I had a very nice supervisor over there, very highly qualified, both of them Oxford graduated. So they really give me very good coaching indeed for the sustainable energy technology, for the theoretical application. But unfortunately, I didn't have any kind of chance to apply the industry because I was a student. But basically all of my, application, it was happened in America. So Joel, that's the best thing I can give you the answer at this time.
Okay, I'm gonna put you on the spot. You're preaching to us that we need to save our planet. What are you personally doing in your home, in your living space, to save the planet? And what is your recommendation for the rest of us?
Simple is that, when I came to this office, I always turn off all the powers. First of all, I turn off all the powers and everything, make sure that there is no unnecessary energy waste. So everybody should practice this one, because if everybody, we have 6 billion people on Earth. And if we really do not think about the saving things, it should charity begin some. Everybody should practice, should know that what I'm doing. So when anybody goes for any kind of, restroom or whatever, thinking unnecessarily for the 2 minutes, running water is completely waste. So we have to think about that. Let me give you another example. Within the last 2 decades, the groundwater lowering down approximately 20 feet. 20 feet groundwater lowering down. So it means that there is another research I have actually is within the next 350 years, we will be a severe shortage of the groundwater. So do you think about that? If we are shortage of the groundwater, so it means that we'll have a severe problem for the drinking water. So therefore, we should think about that, say energy, whatever we're consuming at this point, because we are at 98% energy we are using at this time, fossil fuel. So we have to think about that. So in house or whatever it is, we have to change our habit. So at least for personally, whatever I can save the energy for myself, let's do it. That's I practice.
Okay, good. Ryan, I think that was your question. I phrased it a little bit differently. With that, I don't see any other questions rolling in. I'm gonna call it and say thank you very much, Faruq. This has been really interesting. I love your passion. I love that you have decided to forsake industry and come to KSU and teach the next generation of students to have a sustainable lifestyle and work towards saving our planet. So I really appreciate you and thank you for being on our show today.
Thank you very much. Thank you all. It's my pleasure. Thank you.
All right. And for those of you who are still with us, before you leave, let me tell you that on March 19th, we're going to have Brian Moore. He is an assistant professor of psychology, and he will be discussing his research focused on advancing our understanding of how stressors impact members of the military and their families. Very interesting topic. We've got some military bases right here around us. And Brian is a new faculty member and is doing some great work already. So until then, on behalf of the Office of Research, we wish you a safe and healthy and happy weekend. See you all at the football game tomorrow.
Thank you.
Take care.